Qualitative theory of p-n junction or formation of p-n junction. How this p-n junction will be formed. For a pure silicon atom, if one half of the atom is doped with p-type material and the another half is doped with n-type material, then in between them a junction is formed, that is p-n junction. The plane is divided into two halves or zones, that is called p-n junction. P-type semiconductor consists of both holes as well as negative acceptor ions. The acceptor impurity atom is short of one electron and becomes a negative ion. Since P-type impurity contains boron atoms, trivalent atoms are acceptor atoms, they are having one vacancy of electron, that is, they're having one hole. So they are immediately waiting for accepting a electron. In similar way, n-type material also contains trivalent atoms as impurities. So one free electron is present for every atom. N-type material consists of both electrons and one positive donor ion. That is, donor impurity or trivalent impurity atom donates one electron and becomes positive ion. Hence, n-type material has a high concentration of free electrons, while p-type materials have n-type materials have high concentration of electrons and p-type materials have high concentration of holes. The process, therefore, at the junction, there will be a tendency for free electrons to diffuse over to p side and holes to n side. This process is called diffusion. As the free electrons move across the junction from n side to p side, positive donor ions are uncovered. Hence, a positive charge is built on the n side of the junction. At the same time, free electrons crosses the junction and uncover the negative acceptor ions by filling in the holes. Hence, a net negative charge is established on p side of the junction. Now, p charge on the n side repels holes to cross from p-type to n-type, and negative charge on p side repels free electrons to enter from n side to p side. Thus, barrier is set up against further movement of charge carriers. This potential is called barrier potential or junction potential or potential barrier, that is V0. If you can see, this is a p-type material which contain holes. This is n-type material which contain electrons. Due to diffusion at the center, the electrons from n-type material gets diffused to p-type and p-type material holes get diffused to n-type. That's why these are gets neutralized. If this hole further try to move towards this n-type material, then this positive charge will oppose this hole. In similar fashion, this negative electron try to move towards this side, p-type side. This negative charge formed will oppose. So to cross this junction, any charge, either it may be hole or it may be electron, it requires some voltage that is called junction voltage or barrier voltage or potential barrier. Barrier potential indicates the amount of voltage to be applied to cross the p junction to restart flow of electrons and holes across the junction. Barrier potential is expressed in volts. It is called height of the barrier. The magnitude of the barrier varies with the doping levels of temperatures. The potential barrier can be increased or decreased based on external voltage. The potential barrier is approximately 0. At room temperature, it will be 0.3 volts for germanium and 0.7 volts for silicon. Inside a potential barrier, there is a positive charge on N side. This is the charge, positive charge on N side and negative charge on P side. There is a positive charge on N side and negative charge on P side. This region is called depletion region or phase charge region. This region is called depletion or phase charge region. The thickness is about 1 micron, that is 10 power minus 6 meters. This thickness is 1 micron. Now, if you come to analyze the p-n junction diode, in p-type we are having holes as well as acceptor ions. Acceptor ions in n-type we have electrons as well as donor ions. Coming to general shape of charge distribution in junction. Since the negative charge, the charge distribution is negative. Since it is positive charge, it is positive charge distribution. Coming to electric field, here the more electric field coming towards the center, the field will be reduced. Coming towards this, again the field will be increased. That is, here it acts as a negative plate and here it acts as a positive plate. Now comes to watch about potential for holes in depletion region. In this side, there are electrons. In this side, there are holes. So gradually we go from this side to this side, P side to N side, we are getting holes incrementing. Coming to barrier for free electrons. From P side, it will be P side of depletion layer. The electrons will be high and concentration will be reduced whenever we are moving towards N side. This is the graph. This is all about p-n junction formation.